Exercise 4.6. For solving question number 9 till question number 12, we need the reduction formulas from question number 5 till question number 8 that are already solved in the previous part of this exercise. You can consult that for the reduction formulas of tangent nx, secant nx, cotangent nx, cosecant nx. Use that reduction formulas for solving question number 9 till question number 12. So let's solve from question number 9. Tangent 6 of x dx. For solving the tangent 6 of x dx, we need the reduction formula, that is tangent nx dx is equals to tangent n minus 1 x over n minus 1 minus integral tangent n minus 2 x dx. Now n here is 6, so put n is equals to 6 in equation number 1. We will get here tangent 6 of x dx, that will be equals to tangent 6 minus 1 will be 5 of x over 5 minus integral, and here we will get tangent 4 of x dx. Now we need to evaluate this integral. For that purpose, put n is equals to 4. Here n is 4, n is equals to 4 in equation number 1 for that part. This will be equals to, this thing will remain as it is, tangent 5 of x over 5. Now negative sign, negative, and this complete answer, and that complete answer will be this reduction formula when we put n is equals to 4 in it. That will be equals to tangent cube of x over x minus integral. Here we will get tangent square of x dx. Now open that brackets, we'll get here tangent 5 of x over 5 minus tangent cube of x, this is 3 over 3, and here we will get plus. Now tangent square of x can be written as secant square of x minus 1, like this, d of x. So this thing will be equals to tangent 5 of x over 5 minus tangent cube of x over 3 plus integration of secant square of x is tangent x, and integration of 1 is x plus constant of integration. So this is the integration for question number 9. Now move on to question number 10. The same, in the similar manner, we have to solve our question number 10 by using the reduction formula that we did in question number 7. Now the reduction formula for cotangent n of x is cotangent n of x dx, that is equals to minus integral cotangent n minus 1 x over n minus 1 dx minus integral cotangent n minus 2 of x dx. Call it as equation number 1. Using that reduction formula, we have to evaluate it. Now n here is 5, so put n is equals to 5 in equation number 1. We will get here cotangent 5 of x dx equals to minus cotangent, this is not the integral sign, cotangent 4 of x over 4 minus integral cotangent 3 of x dx. Now for evaluating this, put n is equals to 3 in equation number 1. For that purpose, we will get here minus cotangent 4 of x over 4, and here in this part negative sign and this complete bracket. Use this n is equals to 3 in this equation, we will get here minus cotangent square of x over 2 minus integral cotangent 3 minus 2 will be 1 cotangent of x dx. Now this will be evaluated as minus cotangent 4 of x over 4 minus minus plus cotangent square of x over 2 minus minus plus, now integration of cotangent of x dx. This will be equals to minus cot cot 4 of x over 4 plus cot square of x over 2 plus ln sine of x. You know that integration of cotangent x is ln sine of x, plus constant of integration will come here as it is. Now for question number 11, secant 6 of x dx. This, now using the reduction formula from question number 6, reduction formula for secant n of x dx is equals to secant n minus 2x tangent of x over n minus 1 plus n minus 2 over n minus 1 integral secant n minus 2 of x dx. Mark it as equation number 1. Now n is our 6, so put n is equals to 6 in equation number 1. We will get here integration secant 6 of x dx, that will be equals to, now put in place of n 6, we will get here secant 4 of x tangent of x divided by 5 plus 4 over 5 integral secant 4 of x dx. Now for solving this one, put again n is equals to 4 in equation number 1. We will get here secant 4 of x tangent of x over 5 plus 4 over 5 main brackets. Now n is equals to 4 here. We will get here secant square of x tangent of x over 3 plus 2 over 3 integral, here we will get secant square of x dx, and this bracket close here will come. Secant 4 of x tangent of x over 5, here we will get 4 secant square of x tangent of x 15, and plus we will get here this. Now this integral when we solve it, this will become tangent of x and plus constant of integration. So this is the answer for our question number 11. Now we need to move on question number 12. For solving question number 12, we need the reduction formula from question number 8. Cosecant 5 of x dx. Now we will use the reduction formula that we have already solved in question number 8, that is equals to cosecant n of x dx. This is equals to minus time cosecant n minus 2 of x cotangent x over n minus 1 plus n minus 2 over n minus 1 integral cosecant n minus 2 of x dx. Mark it as equation number 1. Now n here is 5, so put n is equals to 5 in equation number 1. We will get here cosecant 5 of x dx, that will be equals to minus cosecant cube of x cot of x over 4 plus 3 over 4 integral cosecant cube of x dx. Now for solving this one, put n is equals to 3 in equation number 1. We will get here minus cosecant cube of x cotangent x over 4 plus 3 over 4, now the main brackets, and we will use the answer here. We'll get here minus cosecant cube of x, this thing. Now n is equals to 3 here, so 3 minus 2 will be simple cosecant of x cotangent of x and divided by 2 here plus 1 over 2 cosecant of x dx here. Now open these brackets, we will get here minus time cosecant cube of x cotangent x over 4 minus 3 over 8 cosecant cube of x cotangent x plus 3 over 8 integral cosecant of x dx. Now this term will be equals to minus cosecant cube of x cotangent x divided by 4 minus 3 over 8 cosecant, this is simple cosecant x, cosecant of x cotangent x, then we will get here plus 3 over 8. Now integration of cosecant x will be equals to ln tangent x by 2 plus constant of integration will come here in this answer. Now from question number 13 till question number 24, integrate with respect to x. Now these questions are different from the previous questions. Let's just start from question number 13. We need to integrate 1 over a plus b sine of x. Let's name this integral. Let I is equals to integral 1 over a plus b sine of x dx. Now we can write this integral as I is equals to integral 1 over a into 1. We can write it like this. Plus b, we can write sine this x 2 into x by 2. We can write it like this because we know that this will be cancelled and we get back this x. Now we can write, we know that sine square of x plus cos square of x is equals to 1. Also, if I want to write here sine square of x by 2 plus cos square of x by 2, we can write it like 1 as well, because I am using here the half angle identity. So I want here the half angles as well. So I can write it like 1 over a into cos square x by 2 plus sine square of x by 2 here, plus b. Now sine 2x by 2 can be written as 2 sine of x by 2 cos of x by 2 dx. Now I is equals to integral 1 over a cos square x by 2 plus sine square x by 2 plus 2b sine of x by 2 cos of x by 2 dx. Now I am dividing my numerator and denominator. Dividing numerator and denominator by cos square of x by 2. This term will be 1 divided by cos square of x by 2. This term divided by cos square of x by 2. This term divided by cos square of x by 2. This term divided by cos square of x by 2, like this. I am dividing my numerator and denominator with cos square of x by 2. So after dividing, I will get here integral I equals to secant square of x by 2 divided by a plus a tangent square of x by 2 plus 2b tangent of x by 2. This is in multiplication, so only one cos square of x by 2 will come here, not 2 times. Dx. Now we need to simplify this integral. For that purpose, I am letting it equals to some other variable. Substitution. Let tangent x by 2 equals to z. After derivative, I will get here secant square x by 2 and half dx is equals to dz. So here I will get secant square of x by 2 dx equals to 2 dz. So I will use these two substitutions here in this integral I. After using these substitutions, I will get I equals secant square of x by 2 dx is equals to 2 dz. So this will be 2 dz divided by a as it is. Now a tangent square of x by 2 will become a z square plus 2b, and this tangent x by 2 is z. So my integral is reduced into I is equals to integral 2 dz over a plus a z square plus 2bz. Now using completing square method, I is equals to take the common outside. I am also taking this a common outside. So this will be 2 over a. Now inside will be left with 1 over. Here I will get 1 plus z square, and here I will get plus 2b over az. Now I will use my completing square method here. This will be 1 over. I am separating these two terms. This term I can write it like separately z square plus 2b over az and plus 1 this separately plus 1. Now I need to complete its square here. This term I know that I can write it like z whole square plus 2 into z. Now I need some term here so that I can get back this term. For that purpose I need here b over a. So it means for completing square I need b over a whole square. If I am adding it, then I need to subtract it as well. For that purpose I will get in my integral I is equals to 2 over a integral 1 over. Here I will get z square plus 2b over az plus b square over a square, and I need to subtract it as well, b square over a square, and this plus 1 will come as it is. So after simplification, completing square, closing the formulas, I will get here 1 over z plus b over a whole square plus a square minus b square over a square dz. I just simplified this like this. Take the LCM and I will get here. Now cases arise here. Case 1. Why cases arises here? Because I don't know what is the answer for my A and what is the value for B. So I don't know that what sign I will get here if I subtract them. So the case 1 is if A square is greater than B square. If A square is greater than B square, mark as equation number 1. If A square is greater than B square, this means A square minus B square will be greater than 0. So I can make the square root here because it will be positive always. So my integral I will be equals to 2 over a integral 1 over z plus b over a whole square plus, now I can write the square root here. Square root a square minus b square over a whole square. I can write it like this, dz. And I know that its formula, this is the similar to 1 over z square plus a square dz. That is equals to 1 over a tangent inverse z over a plus constant of integration. So using that formula, I will get here in my answer I is equals to 2 over a, 1 over a. A here is this, 1 over a, that is a square minus b square over a, tangent inverse that variable over this a. That is equals to z plus b over a divided by a square minus b square over a. After simplification and substituting back my substitutions, that were, I know that z was equals to tangent x by 2. So substitute back our z value and simplification will give me I is equals to 2 over under root a square minus b square tangent inverse a tangent x by 2 plus b divided by under root a square minus b square. So this is the answer for my this question number 13 for case number 1 only. Now for case number 2. For case 2, if a square is less than b square, if my a square becomes less than b square, then this means this term will become negative. So just take the negative sign common. Negative sign common. That is, we have here plus b square minus a square over a square. Now this term is making the whole thing negative because I have said that a square is less than b square. So this will be negative time b square minus a square now. Now alter their signs. Take the negative sign common. In the start we have here a square minus b square over a square. Now here written that a square is less than b square. It means this is greater. Greater terms is making the whole term negative. So just alter this sign, take the negative sign common. Inside we will be left with b square minus a square over a square. Now this term holds that if a square is less than, then this answer will be positive. So I can write the square root here. So our integral now become 2 over a 1 over z plus b over a whole square. Now here in the start was plus a square minus b square over a square. Now change it to minus b square minus a square over a square. Now I can just write it in the square root. It will become equals to I is equals to 2 over a integral 1 over z plus 2 over a whole square minus under root b square minus a square over a whole square dz. Now this here we need to use a formula for integral 1 over x square minus a square dz, that is always equals to 1 over a ln, that is 1 over 2a ln x minus a over x plus a. So using that formula here we will get 2 over a 1 over 2 into b square minus a square over a ln z plus b over a minus b square minus a square over a divided by z plus b over a plus b square minus a square over a. Now put the value of z here. In place of z, substitute back, and after simplification we'll get here 1 over b square minus a square under root ln a tangent x by 2 plus b minus under root b square minus a square divided by a tangent x by 2 plus b plus under root b square minus a square plus constant of integration. So this is the answer for our question number 13. In this manner we can move on for the further questions.